My name is Ian Lovell, and my project is titled Impacts of Packaging and Light Conditions on Shelf Life Ground Beef. And my mentor is Dr. Cody Gifford of the Animal Science Department. So shelf life can be defined as when a product, or meat in this case, is initially packaged until when it's deemed unacceptable due to the product's properties by the consumers or producers. Some common shelf life characteristics of meat is overall appearance, texture, flavor, color, and nutritional value. Some unacceptable characteristics, which will show up a lot in my study, is spoilage. And not all microbes are considered spoilage. There are some, for example, lactic acid fermenters used in fermented meats, or molds that grow on aging meat aren't considered spoilage, but most are. Lipid oxidation is another example. I'm sure most of you have heard of oxidation, and that's the same thing except with lipids in this case, and will or can result in an off flavor or off taste of the product. Another is color development or off color, and as time progresses due to oxygen, photooxidation, and oxidation, the color will change from beef's signature cherry red to kind of a dark brown color, and that's a negative attribute or negative characteristic. And then shelf life curve is just all these characteristics over time and how that changes. So my project overview is, or the objective of my study is to assess shelf life characteristics and that are influenced by microbial growth, lipid oxidation, and ground beef packages over time. It's also to assess photooxidation from packages displayed under LED, fluorescent, and dark storage, and how that further influences microbial growth, lipid oxidation, and this is done because it resembles the traditional oxidated retail display environment. My hypothesis is that the shelf life curve of ground beef will be influenced by microbial growth and lipid oxidation over time within different types of packaging, and will be influenced by LED and fluorescent and fluorescent lighting. So these are a few packaging types that I'll be used in my study. I'm sure most of you or some of you have seen this before. The top left is a chub, and it is a package that's non-permeable to light but permeable to oxygen. The bottom left is permeable to light, but it is anaerobic, so non-permeable to oxygen. There's some oxygen in there from when it was packaged, but not enough to be significant. And then the bottom right is overwrap in styrofoam packaging, and this is permeable to light and oxygen. So there are two phases of my project. Phase one would include evaluating packages of ground beef chubs in dark storage from 6 to 21 days after the grinding period. Measurements of microbial growth, lipid oxidation, and objective color changes will be recorded. And then at specific time points during this, the remaining chubs will be repackaged into overwrap styrofoam tray packaging and subjected to LED fluorescent lighting for 24 to 48 hours. Measurements of microbial growth, lipid oxidation, and objective color changes will be recorded. Part two, or the second phase, is evaluating effects of photooxidation from vacuum sealed packages of ground beef exposed to LED, fluorescent, and dark storage, which would be our control in this case, for 6 to 24 days after grinding. Measurements include the same microbiological analysis, lipid oxidation analysis, and objective color change measurements. After these measurements are taken, the remaining beef from the vacuum sealed packages will be placed into overwrap styrofoam tray packaging and subjected to LED and fluorescent light for 24, 48, and 72 hours. The same measurements will occur on this. So here are a few of my sources, and if you have any questions, feel free to email me or you can ask them during the symposium. Thank you.